So there we already addressed the goals or our intended learning outcome for this discussion. We already understand the underlying concepts on the design of a pre-stressed concrete element with respect to flexure, as well as we are able to design a pre-stressed concrete element with respect to flexure. So we were able to address our goals for this meeting. So just to recap or summarize our discussion for this meeting, we have learned that it suffices in the flexural design of reinforced concrete members to apply only the limit states of stress at failure for the choice of the section, provided that the other requirements such as serviceability, shear capacity, and bond are met. But in the design of pre-stress members, however, additional checks are needed at the load transfer and limit state at service load, as well as the limit state at failure, with the failure load indicating the reserve strength for overload conditions. All these checks are necessary to ensure that at service load, cracking is negligible and the long-term effects on deflection or camber are well controlled. So to design or choose the section, a determination of the required minimum section modulus (SC and ST) that can withstand all the loads after losses must be made first. So in order for us to solve for those minimum section modulus, we can use two scenarios. We can use two scenarios wherein the beam that we are designing has a variable tendon eccentricity which must have a minimum section modulus equal to these formulas that we have derived, as well as the uh, uh, maximum eccentricity equal to this in order to assure that the stresses that will be experienced by our concrete element that we are designing will not produce stresses are uh, that are exceeding the allowable stresses specified by the code. So other than that, we can also use this formula that we have derived or shown a while ago. And then for the case of beams with constant tendon eccentricity, the section modulus formulas that we can use for designing at service load design are this and this. So the maximum eccentricity to ensure that the stresses that will be induced on the concrete element that we are designing will not exceed the allowable stresses specified by the code can be equal to this. So this is the eccentricity that can be used to find the, the, the proper eccentricity that will produce stresses on the concrete element that we are designing, uh, which will uh, which will not exceed the allowable stresses specified by the code. So that's all for this meeting. Thank you for listening. If you have questions, clarifications, and any other concern, please do not hesitate to contact me via discussions on the Canvas, or you can just search my name on Facebook or Messenger. You can just search Adams Reyes Año Nuevo Junisio and message me there, or you can email me at my email arjunisio.ce@tip.edu.ph. So that's all for this meeting. Thank you for listening and have a good day.